Hi guys, this is your DK again. In this video, we are going to see how to build a simple neural network using PyTorch. Before getting started, let's try to understand our input data. Here, I have a two Excel sheets, one with train X and I have other thing like train label. So basically, train X has my input data and the corresponding label or the output is in the train label Excel sheet. So what does this train X data contains is the it is an elongated version of the minis data set. So what we have done is like we have taken the minis data set which is nothing but a pixel representation of a numbers. So it is a 28 comma 28 matrix. So we have flattened it such that a single row in this Excel, if you look at this particular single row which is of a size 784, which is 28 comma 28 matrix, corresponds to a particular number. So the corresponding label is given over here. If the zeroth position is 1, then the particular data belongs to number 0. And if you see here, if number 1 position is set to 1, so the corresponding number is 1. Basically we have done one hot encoding over here. Now let's try to read this data and visualize in our NumPy and Matplotlib code to get more understanding on this. Let's get started with the hands-on. Let me import some of the mandatory packages. Let me do import torch, and what I'm going to do is like import torch.nn as nn. So basically torch.nn is nothing but a neural network layer which has been pre-built in torch library, and I'm going to import something like torch vision. So torch vision is basically used to read the data and change the shape and visualize the data using torch. So let me try to import one more package like torch vision dot transforms as transform. So basically this is the one which is going to transform the data shape or the data structure. So next what we're gonna do is like we're gonna import some more packages, which is import torch.utils.data, sorry, from import tensor dataset comma data loader. So basically we're gonna convert the data into a torch data set loader in order to process it in the neural network, torch neural network. And also let me import numpy as mp. So I have imported almost all the packages. Now let me try to read the data using numpy and visualize the same. So it's np.loadtxt. I'm gonna pass the name of the file, which is train underscore x.csv. This is the name of my file, and I'm gonna pass the delimiter, which is it is comma separated. Okay, the train data has read successfully. Let me try to read the y train also, which is my label. So I'm gonna rename the file name alone. Okay, train label. So I'm gonna read my train and x train and y train label. Let me do the same for x test also. I do have separate data set for testing, so I'm gonna read the same. Okay, let me rename it to test over here and y test over here. Let me run it. So the data has read successfully. Let me try to print the shape of it. So what I'm gonna do is like print fine dot shape. You can see it is 1000 comma 784, which means I have 1000 records. Each record is of size 784, which is 28 into 28. When you multiply 28 into 28, you will get 784. Let me try to print the shape of this one. A shape. It is given. Again, it has a 10 records and the label is of 10. Since we have done one hot encoding for 0, it will be the first position will be set to 1. So now what I'm gonna do is like I'm gonna visualize the data. So I'm gonna take the data and I'm gonna transpose it explain dot transpose. So now what I'm going to do is like, let me, okay, explain. Let me import random, and let me try to get the random data from here. Random dot ran range 0 comma img dot shape of 1. Let me, I'm just picking one particular record from there, and I'm trying to visualize the same. Let me see whether I have imported matplotlib. I haven't imported matplotlib. Let me import matplotlib also. Matplotlib pyplot as plt. Okay, so let me do the same. Plt.im show is how you will show the data actually. Okay, matplotlib, my bad, there is some typo over here. Matplotlib. Okay, so again, uh, random.ran range 0 comma img dot shape of 1. Okay, index, then I'm gonna give img. Okay, so I need to pass comma over here, my bad. X required one missing position mark of PL. Im show, Im show img comma index dot reshape 28 comma 28 cmap equal to gray. Let me see what is the issue. I am sure missing one required positional argument. Sorry, it should be plt dot show. Okay, you can see here, right? So basically, I'm randomly picking some records from my Excel sheet. That's what I have done over here. Random.ran range. I'm gonna randomly pick something, and I'm gonna reshape it actually. Reshape that particular index into 28 comma 28 matrix. I'm going to display the same using matplotlib. If I run the same again, it's gonna take some other number. So this is nothing but number 8, and let me run again. So this is nothing but number 9. I need to convert the data into a torch dataset loader. So what I need to do is like, mm, train data tensor equal to torch dot tensor, and I'm gonna pass this extrain. Let me pass this extrain. So basically I'm converting this extrain, which is a numpy of tensor, into a torch dot tensor. So let me run this. The code ran fine. Let me try to copy paste the same for train labels also. Label.tensor equal torch.tensor. I need to pass this one. White train. White train is my label, and I'm gonna convert into this data set. So next, what I'm gonna do is like, I need to convert this torch tensor into a tensor data set. So what I can do is like, train data set equal to tensor data set, and I need to pass both the things. So I need input and also the output. So this is going to convert packet into a train data set. So again, I'm going to have a batch size of 32. If I have multiple records, it's going to take 32 records and train based upon it. So next, what I need to do is like, train data loader equal to, I need to give data loader. Basically, it's going to load the data into trainable format. I need to pass this train data set, and I need to give the batch size. It's a keyword document, so I need to mention key comma argument also, batch size equal to batch size, and I'm going to give shuffle equal to 2 just to make the data random shuffle before training. So the code ran fine, so everything looks good till now. So the data has been successfully read and converted into a touch dataset loader. So now what I'm going to do is like, I'm going to create a simple neural network. So again, import torch.nn as nn. This is how we will import a simple neural network. From torch.neural network, I'm going to import a function over there, torch.nn.functional SF. So I'm going to use torch.functional SF. So what I'm going to do, I'm going to create a simple model. So I'm going to have something like simple model, and I'm going to inherit this nn dot module. So nn dot module is an inbuilt torch library which we are inheriting in order to make our neural network faster. I mean the code to be written in a faster way. So yeah, what I'm gonna do, I'm going to inherit it. So I'm gonna inherit the simple model over here using a super function, comma self dot underscore init underscore underscore. So what we're gonna do is like I'm going to define a two hidden layer. So let me name my first hidden layer as self dot c1 equal to nn dot linear is nothing but a simple hidden layer which I'm going to build. So my input shape is 784 and my first hidden layer output shape I need something like 256. So let me build one more output layer. So self dot fc2 equal to nn dot linear is again a hidden layer and I'm gonna give something like 256 comma 10 since my output shape is 10. So here we should be bothered about input and output shape. My input shape is 784, so I gave something like 784 over here, and my output shape is 10, so I gave 10 over here. And hidden layer, it's up to the developer's choice. I'm leaving it as 256. If you wish to change it, you can change and try out the same. Let me have a simple forward neural uh, network formula written over here. So I'm gonna get the x. So if you see y equal to mx plus c and doing an activation on top of it. So what I'm going to do, I'm going to do a ReLU activation and I'm going to multiply it with self dot fully connected layer. So I'm going to pass this x. So what is going to do, it is getting converted into a wx. Okay, so I'm going to pass this x. So it is going to the nn dot linear layer and it is going to have that wx plus p calculated and forward and backward propagation happening everywhere over there. And let me do the same for second layer also, self dot fc2 comma x. So basically it's going to the input layer and it is getting come. So basically I'm passing this input layer to the first hidden layer and output of the hidden layer I'm passing it to the output layer and I'm going to give the output outside using return x. Let me try to create an object for the same simple model, open close bracket, the code ran fine. So we are well and good shape till now. So we need to define the like optimization techniques on the loss function. So I'm going to import the same, import torch dot optim as optim. So what I'm going to do is like criterion is like which loss function you need to use. Obviously it is a cross entropy. So I'm going to mention something like cross entropy loss. Okay, so next what I'm going to do is like which optimizer I need to use, the gradient descent optimizer. We can go with SGD or with Adam. So I'm going with an Adam now. Optimizer equal to optim dot Adam model dot parameters. And I'm going to give the learning rate something like 0.001. So this is my learning rate. Let me run the same. Okay, the code ran fine. So we have the neural network architecture which has been defined and we have the loss function which has been defined. Now we need to execute the code. So for testing purpose, I'm gonna give number of epochs as 10 over here. So now what I'm gonna do is like for epoch in range of number of epochs. So what I'm gonna do is like initially I'm gonna have a total loss defined as 0 0.0. So now for each and every input and label. So for input comma label in train.data loader. So train.data loader is something we pack our input data into a touch data set loader. So what I'm gonna do is like first I'm gonna do the gradient optimizer dot zero grad making the gradient draw to the gradients. And next what I'm gonna do is like I'm gonna have the forward propagation happening. So what I need to do is like outputs equal to model of input. So basically I'm gonna okay input and rename it as yes, just to avoid the confusion over here. And what we're gonna do is like once forward propagation has happened, I need to calculate the loss equal to criterion outputs which I get in the previous step, and I need to pass the label. So basically this is the predicted output, this is the actual output, which is my labels. So I'm gonna get the loss. Once I get the loss, I need to do the backward propagation. This is very simple when it comes to PyTorch. It is just loss dot backward. That should be fine. We are done with this, and we need to update the weights. So once we done the forward propagation, we will do the backward propagation, and we need to update the weights. uh, by After that we need to do the forward propagation again, right? So how we can update the weights, like it's just in a single line of code, which is optimizer dot step. So this optimizer dot step update the weights. Let me put some comment over here, update the weights, and this is nothing but the backward propagation, and this is nothing but computes the loss for me, computes the loss, and this is nothing but my forward propagation, and this is nothing but zero the graphs. Okay, so everything is done. So I need to calculate the loss. So let me try to calculate the loss. Total loss equal to sorry, plus equal to loss dot item into input dot size of 0. So this is used to accumulate the loss. Okay, so once everything is done, so for each and every epoch, it is going to run the same. Let me calculate the average loss. So how to calculate the average loss is like total loss I have calculated in the above step divided by length of train data set. So divided by 1 by n, that's what it means. So let me try to print the loss over here. So let me print epoch this epoch epoch. My bad, that's a spelling mistake over there. And loss value is, let me print the average loss. It should be an average loss, abg comma loss. Okay, it should be formatted of but 4f. Let me try to do this one. So what I can do is like hmm, okay, it should be good, but why it is throwing the same. Okay, let me print the average loss alone. I don't want to do some fancy things over here. Let me run this. Okay, criterion is not defined. Criterion, so I defined it over here, right? Criterion, that's a spelling mistake over here. Let me try to fix this. Okay, criterion again, label, it's not labels. Labels, let me run, make it as labels over here. Okay, again, input size is not defined. Oh, it is input dot size, inputs dot size. Okay, so there is a reduction in loss for 10 epochs. So now let me try to predict with the test data set. In order to predict the test data set, I need to convert into a test data tensor. So let me do the same for test data set over here. So let me rename it as test. Again, here it should be a test over here. So this is done. So I have created the test data sensor. Now let me try to pick some random records from the test data. So I'm going to copy paste the same code below. So instead of train, what I'm going to do is like I'm going to pass the test. Okay, now here it is taking some random number of 0. Now let me try to predict it actually. So how I can predict it is like I need to do a forward propagation. So I need to take a single record from the train test data tensor. So what I'm going to do is like one record equal to test data tensor, the particular index, and let me squeeze it. So here it will be like dot and squeeze of 0. So this is done. So now I need to do a single forward propagation. Already my model has learned the weights. So I don't want to do any backward propagation. So I'm giving with no grad, and I'm going to do prediction equal to model of, I'm going to pass this. So it is going to do the prediction for me. So I need to get the argmax. So prediction label equal to torch dot argmax, which is prediction, and I'm going to give dim equal to 1. My bad. So I need to paste this one. Oh, sorry. I need to give prediction. Prediction label is fine. So what I need to do is like I need to convert into a numpy of array, and I will get the 0th index. It is able to predict it as 0. Now let me try to do for another number randomly. So I'm taking number 6 now. Let me run the same. It is predicting it as 6. Now let me take another number. It's number 5, and it is predicting it as a 5. So that's it with today's demo, guys. Thanks for watching the video. If you do like the video, kindly do subscribe the channel for upcoming videos. Thanks for watching the video and happy learning.